We have a very strong basic understanding of Swift. We can now go into our project and start looking at all the different code files and start coding up our app. If you followed with us on the previous Swift module, go ahead and leave the playground and go back into our previous project. Remember that viewcontroller.swift file? We can now start opening it up and looking at the code that's already in there. So when you open up your viewcontroller.swift file, you'll see that there's already a class that's created for you called viewcontroller. This gives you some general class creation for a view controller. If you noticed in our class, there's something that's added here, right here. This :UI view controller. In our previous module, we discussed about inheritance and subclassing, and this right here means that our view controller is inheriting from a UI view controller. Again, this UI view controller is something that Apple has provided us that allows us to easily create some of these objects, and it has some presets done within this class that we don't have to really worry about, or if we do want to change it, it's really easy to change. If we look in our class, you'll see a few different functions that have already been created for us. The viewDidLoad and the didReceiveMemory warning functions. And if you look, there's another keyword in front of that func called override. When we inherit from another class, we need to override a few functions. This essentially means that we're taking a function that was already provided to us from Apple in the UI view controller, and we're going to be adding more functionality onto it with it for ourselves. If you look inside this class here, you'll notice that there's a few override functions here, a viewDidLoad and a didReceiveMemory warning. So this override is a new keyword that you might not have noticed when we created functions before. Apple provides us a bunch of different functions that allow us to inject some code at certain stages of the app's lifecycle. As it sounds, the function viewDidLoad will be ran when the actual view of this particular controller is loaded. This function right here is a great place we can start by adding our statements in so we can start preparing our cards. One other note, you'll notice that in the viewDidLoad, you'll see this super.viewDidLoad. This is a really important part and should really be left in there. This is also a pretty key part to inheritance. By overriding this function, viewDidLoad, we're basically saying, hey, parent class, we want to add some stuff to this function, but we don't want to get rid of all the stuff that you did for us because there's a lot of useful things that are happening in the parent function of viewDidLoad. Now, calling super is essentially saying that you're calling your parent's function first to do all the setup that you need to, which allows you afterwards to be able to add any other functionality that you want to within this function. Again, this is really important for us because there's a lot of stuff that Apple is doing under the hood in this view controller that we really need to take advantage of. And when we need to, we can add our own code to perform specific actions. The first thing I want to do is add all the quiz statements that we want to use. So typically, a lot of apps will get their data from some type of backend server or various other means through the internet to retrieve the data that it wants. In our case, because this is a beginner's course, I really just want to give you the data first at hand. Now, there's a few disadvantages to this. Because it's being built in the app, we can't just change up the quiz every now and again without building a new app. But in this case, this is just a learning app, so really it's okay. I want you guys to have all the data there first, and then we can actually get into coding. We do need the statements that the user is going to attempt to answer, so we need to add that into our view controller. And remember that I told you that the statements need to be stored in an array. So we're going to create a variable that's an array of strings that's going to store all our statements. I don't want you to type all this out because it's just a bunch of different statements and you really don't need to waste a lot of time typing that out. So if you go into our resources, you'll find the exact array that we need to build out. So I'm going to copy and paste this variable right here. And if you just read through it, you'll notice that it's just an array of strings. This is what's going to print out on the card, and the user can see these statements and go through and be able to answer these. To make sure that the app actually loads up and is doing what we expect it to do, I want to print out these statements into our console when we initially load our app, just to make sure that we are doing everything correct. To do this, I'm going to use a for loop similar to what we've looked at in the previous Swift module and just print these out. So for statement and statements, excuse me, I want to continue myself keeping good coding behavior, and it's going to be self.statements because statements is the local variable for our class. I'm just going to say print statement. So nothing crazy here. We're just going to do a simple print. So it should go through every statement in our array and print it out when the app loads up. So let's try loading this up and seeing if this works. So if I go ahead and hit the play button here and run the app, we can take a look. Okay, so in the simulator, you'll notice nothing really happened. But if we go into our console, you'll notice that right here, all our statements are getting printed out. Cool, so we know that this function right here is actually running when our view loads up. The next thing that we're going to do is create all the statement cards. And to make things a little bit simpler, I'm going to create a new file so that way we can have all the code for our cards in a different file. So I'm just going to go File, New, File, and you'll be brought up with a bunch of different options. The one we're going to want is the Cocoa Touch class option. Now the Cocoa Touch class is simply just some of the Apple provided classes for the user interface. Now it's going to pull up and ask for a name of our class. And in this case, we want something, again, that we can refer to and we know. In this case, we can call it statement card view. And the subclass, again, we need a parent class that we want to inherit from to make things simpler. And in this case, we want it as a UI view. And we'll just create it. Views have a few key components within the screen. It has a size and it has a position. Size can easily be represented as a width and a height. A position is also represented simply by an X and a Y coordinate. And if you want to think about it this way, think of your iPhone as being a type of canvas or grid, where at the top left, we have the 0, 0 coordinate. And going this way will be your X, going down will be your Y. So this will be increasing in X and this will be increasing in Y. And because every iPhone is slightly different in terms of resolution and size, some of the values do vary based on the iPhone that you have. Also think of the position of our card for the X and Y being at the top left of our view. We can look back at our card and get a general sense of how big our card should be and where it needs to be placed in our view. Our card has a few different pieces to it, one being the text that's on the card, so we'll need to be aware of the position of our text. Also, when the user swipes left or right, an image will slowly pop up indicating to the user whether they're trying to answer true or false. All those you just need to keep in mind. Because we don't have the luxury of a storyboard of just kind of placing things on the view as you see it, we have to be aware of these coordinates in our head when we're building this out in code, because we can't really see anything as we're coding it out. So we just need to have a good sense of the position and the size of where we want to place our view. When we create our object, what do we need to start with again? That's right, our constructor. Yes, that coding buzzword that I talked about previously. As you type init, you'll notice that it pops up with a few different options. And in this case, we're going to want to take this init frame CG rect, and it will automatically insert that for you. Now you'll notice that there's this red dot at the bottom, and if you click it, it'll tell you that there's a warning or an error, and it will say required initializer init coder must be provided by subclass of UI view. So that sounds really confusing. The great thing about Xcode though is a lot of the errors, even if you don't understand what they really mean, you can automatically fix it because it's something that Xcode recognizes. So if I click fix it, it'll insert some additional code that will allow our app to still build. Just to give you an idea of what this actually means, it just means that when we created our constructor, we need to set something up for if we're going to try to create this view in our storyboard as well. And in this case, we're not going to do that, so we could just leave it to what Apple provides us. We need to add some code into our init. Go ahead and delete the part here that says code. Remember, when we override a function in our class, we want to make sure that we still call the super so that we can make sure that when we set up the view, whatever Apple has done beforehand is being done. Like this. This will essentially get everything we need in our view set up. We created this class for the new view we were making, and now we can actually go ahead and add the text, which will be our label for our card. Apple has conveniently provided us with a class known as UILabel to do that. So if we go back in our class, we can create a new local variable called statement label. And this is a type of UILabel. Now this is all pulling up because I've imported the UI kit. So when you create the new views, Apple already provides this for you, but just so you know, in order to get access to these Apple classes, you need to make sure that this import UI kit is at the top. You'll notice that I'm putting this exclamation point after the UILabel. This is known as implicitly unwrapped optionals. Yeah, that's kind of a long thing, and that sounds super confusing, right? Here's a quick breakdown of implicitly unwrapped optionals, or optionals. An optional is something that's very specific to Swift, and it denotes whether a variable may contain something or for sure contains something. An optional is denoted by having a question mark after the type. So if you had an int question mark, this would be an int optional. And what this means is that the variable, if it is an int optional, that it either contains an integer or it contains nothing, or in coding is known as nil. This means that the data does not exist and the variable does not contain an integer. What would be some of the cases for this? One example is if you had some type of user form where you're expecting the user to type in a number, but instead the user types something else or doesn't type anything at all, your app should respond accordingly, not by crashing, but by taking the data and being able to correctly process it. In the case of optionals, you would use it so that you can check to see whether what you got back is, say, an integer or a type you were expecting, and if not, handle that accordingly and responsibly by doing something else. The exclamation point is implicitly unwrapped optionals. And this pretty much means that the variable will definitely have that value. And if for whatever reason the variable doesn't have the value or is nil, it will crash the app. This is something that you definitely want to make sure that you for sure will have the value back. And there are cases where you may think, oh yeah, I'll definitely always have the value back, but sometimes it doesn't come back the way you expect it to. So I highly recommend just making sure you use this sparingly and use it in cases you know for sure you're going to have it. In this case, we know for sure we're going to have it because we're going to create it when the card view is created. So we can do this. I'm going to go ahead and say self.statementLabel. And remember, at the top, I initialized my local variable, but I didn't actually create it yet. So I'm going to create a UILabel down here. And I'm going to want to use the frame. And in this case, I'm just going to take the frame of my card for now. So I'm just going to say frame, or self.frame. I also want to set the background of my card to be a specific color. By default, the background is going to be clear, But in this case, I want the background to be white. This is the great thing about having the UI view parent class, is that Apple has given us all these properties that we can set when we need to. So in order to set that, I'm just going to go ahead and do this. I'm just going to go self. And if I hit the dot, you'll see all the different options that is provided for me. In this case, I'm going to want to type background, and you'll see that something pops up, background color. Now you'll notice that this is a UI color optional. Again, you won't always have a background color, which is why it's an optional. But this is another really cool class that Apple provides for us that provides all the different types of color options. And if we want to make a custom color, we can do that as well. I'm going to say background color is equal to UI color dot. And in here, we have a bunch of different colors we can already choose from. So we don't have to create white by providing like the red, green, blue values or doing anything specific. We can just type UI color dot white. We created the class, but again, we need to initialize or create the objects in our view controller in order to actually see this class. So if we go back into viewController.swift, and where we printed our statements and the view did load is probably a good spot we can start creating our views. Since we already set up the for loop to print the statements, we can go ahead and repurpose this for loop to create our statement card views. Back in our loop, here is how we create our statement cards. I can go ahead and delete this print statement and say var card view equals statement card view, enter. And in this case, we're going to want to utilize the frame. And we want to set the card frame right now because we just want to check to see if it worked. Let's go ahead and set it to our view controller's view size. To get the view, we just need to say self.view. And here we can access the properties for the view. And in this case, we're going to want to do self.view.bounds. What's the difference between like a frame versus the bounds? There are two different properties, so what's like the difference? They're actually very similar. They both provide a rectangular size with, like, again, the width and height and an x and y coordinate for your views. The bounds is very similar to the frame, but there is a key difference. The bounds is in relation to its own view, whereas the frame is in relation to its parent's view. This can get a little confusing, especially if you don't know too much about coordinate system and how kind of to place all the views within a specific coordinate. Just know that bounds are very useful when placing content within itself, and frame is useful when you're placing content within its parent's self. I have my card view created, however, I didn't actually add this view yet, so it's kind of created, but it's not in context anywhere. So what I want to do is I want to actually add this view as a subview to this view controller. So if I go in and say self.view.add subview, and I add the card view, what I've essentially done is I'm taking the card view itself and adding it to our views hierarchy. There is one more thing I need to do. I need to actually set the text of my card views label to the statement. So before I add the subview, I can go in and say card view dot statement label dot text is equal to statement. So again, the statement label was that UI label we created in our card view previously back here. So we have our UI label here. That's what's containing our text. And the UI label itself has a property called text, which takes, if you look, a string. So if I look at the help for the text by pressing Alt and clicking on the text, I'll get a pop-up that says that this text is a string that is displayed by the label. So we can actually set our statements to this text, and then it will actually place it on the card. So there is one key component that we need to do in order to have our label be visible by the card, and that's adding it to the subview. So if I go here and type self.add subview and type in self.statementLabel, what this part is doing here is that I'm creating the UI label, and now I want to add that label to the view's view hierarchy so that it's visible when we actually create our view. So by doing that, it's actually going to add the view in and we can see it. So now, if I play it, let's see what happens. Awesome. You'll notice that on the screen, instead of seeing the background, you'll see it's entirely white, and you'll see Princess Leia and Luke Skywalker are twins. You'll notice, though, that the whole screen is white and the text isn't centered. Let's take a look at why this is. Back in our code, we'll look and we'll see that we set the card frame's entire frame to the view bounds. That means that we're setting the card to be the entire size of the screen. Also, by nature, the label is text aligned to the left, so it's going to be popped up to the left. And if you notice, back in our card view, we set our labels frame to be the card's frame. So it's going to be the same size as our card, which is the size of the screen. So our label is going to be left aligned and it's centered because by nature that's what the label is. To get it to more closely hit what we saw the app should look like, we need to adjust the frames of the card. So we want to shrink the card a little bit on each side so that you can still see the background. And we also want the label to be centered in our card and not to the left. We can now adjust the frame and do some basic math to get what we want. Going back to our frame, there are a few key components that we need to create our frame. We will need an X and a Y and a width and a height. Let's start with the width and the height. We're going to want about 60 point padding from both the left and the right side of our card. And we're going to want roughly about half of the height of what the height currently is. So to reiterate, we want 60 points from each side, which is 120, doing math, points smaller on our width for our card, and about half of the height of our view. The X and the Y can be a little bit tricky. Because the X and the Y from our card is starting at the top left, we don't know exactly where we want to place it because we kind of doing the math might be a little bit harder. Luckily, UI View has a great property called center, which allows us to be able to set the center of our card to be exactly what the center of our view is so that everything is nice and centered. Going back into our view controller, right before we actually do our loop, we can go ahead and create our initial frame for what our card should be. The actual frame is a specific object type, which is CG-rect. And a CG-rect essentially is an object that contains an X and a Y and a width and a height to define it. And in this case, there's multiple ways to create this object. I'm just going to pick the ones with the CG float type. And here, I'm just going to set X to be 0, Y to be 0. And remember, going back to our initial math, we're going to set the width and the height specifically. So here, I'm going to say self.view.bounds.width. So I'm going to take the width and subtract it by 120. And the height, I'm going to do something similar, self.view.bounds.height. And I'm going to divide that by 2. So remember previously I said we want to take the width and subtract it by 120 points. And the height, I want to do that in half. So similar, that's how I'm doing the card frame. We're setting the X and the Y to 0, 0 for now because in a little bit we're going to set the center, which will change the position of our card. So we don't need to worry about that. So when we create our card, we had the initial frame. So instead of using the view bounds here, I'm going to delete that and set the card frame to be our new frame for our card views. And just after this, I'm going to set the center property equal to the self.view.center. So when I create my card view, I'm setting the initial width and height, and when right below it, I'm setting the center of our card view to be the center of our screen. Let's go in and run this and see what it looks like. Awesome, now we can actually see the background again. Here's something I noticed. The text in the label is getting cut off. And the reason for that is the UI label is only set to be on one line. And if it is too small for that line, it's just going to cut it off. In the next segment, we're going to go ahead and make some adjustments so that the text is centered and correctly showing the entire statement in our card. We will need two things for adjusting the text within our label. One, we're going to need to center the text so that it's centered within our card. And two, we're going to want to allow multiple lines for our label so that we can see the entire statement. This is also very simple, and Apple just makes it really easy for us because they provide us with this UI label. So all we need to do to set our text alignment is go self.statementLabel.text alignment. So we'll see that there's this property text alignment, and it's a type of NS text alignment. So I can set that equal to NS text alignment. If I type it right, text alignment dot, and here you have a bunch of different values that you can pick from. So a text alignment, if you've seen like word processors, pretty simple, left, center, right, pretty standard stuff. Here we can just do center. And that will go ahead and center our label. The next thing we want to do is to set multiple lines. And to do that, just beneath here, we'll do self.statementLabel.number of lines. So you'll see that there's a property called number of lines that's an integer. So if we go ahead and set that to 0, that sounds confusing, but 0 just means that you'll let it run off through until it's ended. In this case, we want, because we don't know how many number of lines we will need, 0 just kind of is an arbitrary. So if we hit play again, now you'll see that our text is centered and that we can read the entire statement. So that's quite a bit of progress. So you'll notice that it doesn't look exactly how we would want it or what we were expecting from what we saw in our designs. The edges are still a little sharp, and you can only see the top card, and I kind of want to be able to have a little bit of a stack effect so that you can see that there's multiple cards underneath it. So I want to offset some of those cards a little bit so you can see multiple cards. In the next segment, we're going to go through and make this card look a little bit prettier. We need to adjust our view to look more like a card. Right now it's got a lot of sharp edges because it's fully rectangular. We want to soften those a little bit and add a little bit of a border so that we can actually see the entirety of the card, as well as create more of a stack effect so that we can see a little hint of cards underneath, just to give the user the idea that there's actually something under there. To accomplish this, we need to adjust a property that is a pretty important concept within a view, and that's known as a layer. The layer is a property of our view, and it's an object type of CA layer or core animation layer. The layer is a way of managing the content on our view. Wait, you said the view is the way of managing the content in the view, right? Well, it does. The layer itself adds an additional level of control in terms of managing specific contents within your view. And it's the way that we're going to get the soft edges on our card. There's a lot to layer programming, and there's a lot of stuff within core animation. I don't want to get so much into it that we kind of take away from this mini course. However, I think it's really important that we at least go through some of it so you know that it exists and how it's used in certain ways. Similar to how every view controller has a root view, every view has a root layer. So you can think of it as kind of an additional piece to our view. Going back to our card view, I'm going to want to create some setup for our layers. I want to separate it a little bit from the rest of the code, so I'm going to put this in its own function. So here, I'm going to create a function func setup layers, setup layer. And remember, when we create our function, we have to actually call it so that it runs the code. So going back in here, I can do self.setupLayer, and this will run the function that I have created below. So there's two things that I can do to the layer to give the effect that we want. So one was setting up the corners to make sure that there's more of a soft edge on the corners. And the other is to add a border to our cards to just kind of give a little bit of sort of a shadow effect to make it stand out a little bit more. So here I can say self.layer, and you see that there's this property layer. There's two properties we can affect, or actually three total, that we're going to mess with in the layers, one being the corner radius. So I can say corner radius. And this is if you hover over holding Option and click it. There we go. So if you hold the Option right here and you look at what it is, you'll see that it's a CG float. So it's a decimal number or decimal float. So we can go in here and set this equal to, let's say, 20.0. So I'm just going to set a number and we can actually look at it and see if it kind of make some changes. The other two things I'm going to want to adjust are the border width and the border color. So the border width is just a specific width of our border by a certain amount of points. So if I go in here and say self.layer.border width, I can set this to something like 0.3. I don't want it to be too big. If it's too big, it'll stand out a little bit too much. And I need to set the color as well. So I want to set it to black. So if we do self.layer.border color, you'll notice that before I finish this, it says that it's a CG color. And before we were working with UI colors, well, because we're working with layers, there's sort of another level of colors that we need to work with as well. But don't worry, it's not too difficult. To set the border color to black, I can say UI color.black. And if I type dot one more time, there's a property called CG color. So Apple has provided us with a way to manage both colors in both realms pretty easily. Okay, so I have those set up. Let's go ahead and hit play and see how it looks. It's definitely looking a lot better. You can see that it's looking more like a card with those soft edges, kind of similar to playing cards. And it's kind of hard to see, but you'll know that there is some small little border there that kind of adds a little bit of touch to it. So, and I'm just going to scale this up. I think it's already scaled. Okay. The next thing we want to do is sort of add an offset to our cards a little bit so that we can kind of see a little bit more of a stack effect. Back in our view controller is where we're creating the views and setting the frame up. So if we go back in our view controller, here, you'll notice that we're setting a specific frame and we're setting it to the center. What we want to do here is we want to add some type of offset variable that we can slowly move each card as we're creating them. To create our offset, we can just go ahead and create the variable in our view to load. Var offset, and this is a type CG float, is equal to 0.0. Back in the loop where we're creating our view, you'll notice that we are setting the card view center to our view center. In this case, we want to create a new point, which on every iteration of our loop, we can increment the offset up ever so slightly so that we can stagger the cards going upwards. Rather than setting our card view center to self.view.center, let's create a new center point that will be offsetted at every single iteration of our loop. Right here, I'll go ahead and create a center. So I say let center equals CG point. And if I complete it here, you'll notice that it's going to require an X and a Y. So I'll take the X and the Y. So we still want our X center to be the same. So we can say self.view.center.x. So we can take our previous center's X and just use that. For the Y, though, we're going to want to do a slight increment. So we can do self.view.center.y, and we can subtract the offset that we created above, minus offset. We are creating a new point where the X is going to be the same X as our view's center, but the Y is going to be the view's center Y point subtracted a little bit by the offset that we have. Next, we need to change what we're actually setting our card view center to. So instead of self.view.center here, I'm just going to say equals to center. So now I'm actually setting my card view center to the center that I created up here. One last thing that we need to do is right now our offset is 0, and you won't see any change because it's constantly being 0. So we need to add to this offset. So just before our loop ends, I can say offset is equal to offset plus 5.0. This means that on the first time our loop runs through, our offset's going to be 0, so our card is going to be directly center. But then right after that, it's going to add 5 to the offset, and on the next card, it's going to move it slightly up 5, up 5, up 5, and it's constantly going to do that within our loop. So let's take a look and see how this looks in our app. Great. So you'll notice that now we actually see multiple cards underneath, something that gives you the effect of, hey, there's actually more stuff down here, and it makes our app look a lot more alive than previously. We got a ton of stuff done so far. We've dealt with views, we've dealt with layers, we've dealt with managing the properties, changing the frames. There's a ton of stuff that we went through, and I know that it's a lot to take in, so feel free to pat yourself on the back. You've done a lot of great stuff so far. The app isn't functional yet. You can't tap on the cards, you can't move them around, you can't swipe them off. There's not really anything happening in our app quite yet. This is where we're going to get into even more fun stuff. So in the next module, we're going to go through animations and interactions and actually make this app functional. So see you in the next segment.